linearization, we start with that delta y is approximately dy. So these are two different things. And they're very useful. You'll see them in Calc 2. This part is very useful. So remember, this is f of x plus dx minus f of x. And this, please remember, the differential of y is not f prime of x. It's f prime of x times dx. And all we have to do is put it in, move it to the other side. So f of x plus dx is approximately f of x plus f prime of x dx. Well, same. Okay, so do we want to approximate something using this formula, or we want to find the linearization, the linear function that approximates this function near a, which is basically the same thing. And dx, of course, is x minus a, the distance. So let me know which one you have in mind. They're both extremely important, again, for Calc 2. Is it the linearization that we want to work on, or the linear approximation? Which is basically the same thing. This linear function is this, and approximates the function near x, and this must be small. And x this is dx, which is x minus a. So which one did you have in mind, Gabby?
Can we do the approximation?
Yes. So tell us what you would like to approximate. Do you want a trig function? Do you want a cube root, or what would you like to approximate?
I don't have a specific one, but can we do a trig function?
Yes. So for example, we can approximate sine of, I don't know, 88 degrees. So this side is the sine of 88 degrees. So I'll have to write it as sine of 90, because 90, I know what it is, and minus 2 degrees. And 90 minus 2 is 88. So 90 is my x. Okay, 90 degrees, but we know that this is basically pi over 2. And I know that dx is the negative 2 degrees, which I cannot use. It has to be negative 2 and pi over 180, because it has to be in radians. And this is negative pi over 90. All I have to do now is find these three, which I already have. This is this. This is f of 90. So this is f of 90 degrees. And this is f prime of 90 degrees. Okay. So I have to find f prime. So f of x is sine x. F prime of x is cosine x. F prime of pi over 2, or 90 degrees, is 0. So this whole thing will go away. So it's approximately 1. So then sine of 88 degrees is approximately sine of 90 degrees plus 0 times negative pi over 90. Since this is 0, this is 1. So sine of 88 degrees is approximately 1. But please remember, in this formula, you have to put radians. Inside the trig function, it doesn't matter if I write pi over 2 or I write 90. Inside cosine, it doesn't matter if I write pi over 2 or 90. It doesn't matter. But if it's outside of a trig function, in a relationship like this quantity has to be in radians. Very good question. Other topics that you would like to go over? It doesn't have to be from the previous tests. It can be from test 4. If you need help with anything. Anyone? Caitlin, you have anything? Anything you can think of?
I have one from one of the WebAssigns. Let me look.
I'm ready. If you can give it to me so I can write it down, it's better. But if I need to open it, I can open it. Quinn, will you find something else after we solve Caitlin's problem? Do we have it? Do you have anything else? It's okay if you don't. I'm just asking.
I was wondering if after we go over Caitlin's problem, if we could go over the what was it called? The rate of change in natural and social science.
Oh, rate of change. Okay. Like the one with the particle going back and forth and velocity and stuff like that?
Yep.
Okay. Good. Anything else? Victoria, are you okay? You are muted in case you're talking.
I'm fine, ma'am.
Okay. Do you need help with anything?
Not at the moment right now.
Okay.
If I do, I'll probably should have taken some.
Okay. Thomas, do you need anything? Any help with anything so I can make a list of questions?
I'm good right now.
Okay. Liliana, any question?
I'm good for now. Thank you.
Okay.
Could we do
Thaddeus? Yes?
I don't know a specific problem, but could we do a related rates problem?
Yes. Good. Awesome. Mason? Any questions?
I'm good for right now.
Okay. Gabby, anything else you want to add to the list?
Can we also do one for substitution again?
Yes. So integrals, definite and indefinite, or just one or the other?
Either one.
Okay. So let's look at some definite and indefinite. Good. So Caitlin, when we have the problem or not yet?
Yeah, I have it.
I'm ready.
So, function is x squared plus the square root of 1 plus 2x.
The square root of 1 plus 2x.
And it's from 6 to 8. And it says the use the definition with right endpoints to find an expression for the area under the graph of f as a limit. Do not evaluate the limit.
Right. So how many subintervals, or it doesn't say?
It doesn't say.
Okay. So in other words, the area, this is just the limit as n approaches infinity from the Riemann sum. So I have to write I equals 1 through n. And this is delta x. So remember, this piece is delta x, and this piece will be f of xi. So for delta x, I have to have 8 minus 6, which is 2 over n. So this is 2 over n. And that's the first prep. The second prep is xi. It has to be 6 plus delta x plus I delta x. So this is 6 plus I, and delta x is 2 over n. So I will write it nicer as 6 plus 2i over n. And prep number 3, I have to find this f of xi. F of xi is f of this, 6 plus 2i over n. Since I have this function, I know that this has to be squared, 6 plus 2i over n squared, plus the square root of 1 plus 12 plus 4i over n. I'll come back to that because I need to write a little bit more. So this is, I don't know if they want us to simplify, but I'll simplify it. So 36 plus 24i over n plus 4i squared over n squared plus, and under the square root we have 13 plus 4i over n. This is what I have to put in there. So I'll put parentheses, of course, 36 plus 24i over n plus 4i squared over n squared. That's from here. First term squared plus 2 times the first times the second plus the second term squared. And this is times, plus the square root of 13 plus 4i over n. And that's it. We are not capable of evaluating this. We are capable of evaluating all this, but not with a radical.
Perfect. Thank you.
Thank you. Is that clear? So these are basically the steps that we have to perform before we determine the limit. So delta x, and then xi, and then f of xi. Without these 3 preps, I cannot start the limit.
Yeah, I think I was just kind of confused with the way they were asking the question.
Yeah.
So I didn't know to start that
Yeah.
process.
Yeah.
Thank you.
So every time we are asked the limit of the Riemann sum, you have to have these 3 steps. And this is slightly more difficult than the examples we did in class. Why? I didn't want to torture you, and I started at 0. But if we start anywhere else, then we have more algebra to perform. I have to square a binomial, and etc., etc. Okay? So I chose 0 to something. Good, very good question. Now we want to go back to the rate of change. So that was in 3.7. That if you have a question or a problem that you want to work on, we can choose. You want to choose that particular type with the particle. Do you want to choose this particular one with the particle, a type of problem, or anything else?
Can we do the one with the particle?
Okay, so I don't remember exactly what we did and what we didn't. So this is a cubic function. This is a rational function. I think we did the rational function. I'm not sure. This is a trig function, and this is a product of t squared e to the negative t. So I can open the book, actually. This is in 3.7. Let me open the book, and I let you choose. One more second. I'm clicking here. I hope I'm not logged out. No, I'm not. Of course, I let you choose. And 3.7. I'm hoping you also have, please review the written homework solutions. I wrote them for you after each class when a homework was due, and they're all there step by step. Okay, so here are the 4 functions that they have. A cubic, rational. I think we did the rational. I think one of you chose the rational. I don't think we did the cubic. We probably did this. I think we did the trig function. And I think I assigned this for homework. So you have this in the homework, written homework, I think. Oops. I can't look at that. Okay. So I'm back to the homework. So let's see what we did. I think I assigned 4 for homework. Nope, I lied. I assigned a rational for homework. Sorry about that. So now choose whatever. And I think we did in class the trig then. I think it asked the trig then. So I don't remember if we did 1 or 4, but you can choose.
Can we do number 4?
Yeah.